Welcome again to Tcl Tasks. This is part 2, Tips and Tricks. If you haven't already done so, you should watch the earlier video, Intro to Tcl Tasks, using the link in the description below. In this video, we will again be using the tproc command to create a procedure that will be loaded into one or more tasks or threads. The procedure in this example is a shorter version of one that is on the wiki website that extracts the titles from a series of RFC web pages, where RFC stands for Request for Comment. We will be running on Windows 10, and so we will be using the twapi package, twapi crypto, which is required when a website uses the HTTPS protocol. On Linux, we would use the TLS package instead, as shown on the wiki page. This page can be found here, and here is the code that we're talking about for using it under Linux. We do a package require TLS, and then we do this HTTP register. So let's now turn to our code, which is in our EditPad text editor window. As before, in the intro video, we have packaged the task code in a module, and after specifying a path where to look for the tasks module, we can load tasks with a standard package require tasks command. As before, we will also use the namespace import for convenience, so we don't need to qualify the procedures from the tasks namespace. Again, we use the console for our output, and initially we will hide the TK top-level window. Later we will create a small TK button to invoke a command to line up some text windows that our tasks will be using for debug output. Next, we have a small timestamping proc that we can use in our debug output to print the current clock time down to millisecond resolution. We'll use this in the main and also import it into our tasks. Incidentally, Tcl threads is a higher level abstraction than OS threads in that they don't automatically have access to each other's memory. Each Tcl thread runs in a separate interpreter, and the TSV component of the thread package is typically used to share data between threads. This includes any procs or tcl objects defined in the main. Tasks provide a quick and easy way to get procs imported from the main into our task threads. We will also set up two global variables with the starting and ending RFC numbers, and another variable with the number of tasks or threads we will be creating. Initially, we will use just one task. This will have the same effect as if we were writing a sequential version, so we compare the time we have saved by running these web requests concurrently. As before, we output some info about the version of Tcl we are using, plus the pointer size, so we know when we are using a 32-bit versus 64-bit version of Tcl. Next is some tproc init code that we will come back to in a minute after we look at the tproc code itself. As you might recall from the intro video, a tproc looks just like a regular proc, but includes options that follow the body of the procedure. Tproc creates a standard proc using the name do under URL, which has three args, a URL, a number, and an optional debug parameter that will default to no, which Tcl will treat as the Boolean value false or 0. The body of the tproc is a code which is just standard Tcl code that calls on the HTTP package to get a URL, then sets the variable result to the full text of the web page that was downloaded. The next two statements use the regular expression command regexp to locate and extract the title into the variable extract. If it can't be found, it will leave extract set to an error message. We now have all we need, and we close out the HTTP with a call to cleanup. Next, we check the debug parameter, which again defaults to no, but if yes or true, it will output a timestamp message with the RFC number and the title if found. We will discuss tpause check later when we turn on the debugging text windows. And finally, we will return a value to our caller, which is, in this case, is a list of two items: the size of the web page in characters and the extracted RFC title. Now, following the body of the procedure, we have three items. The first is the option for the number of tasks or threads we want to create, which is in this case is from our variable above, which is at present just one. This can be useful in two cases. First, as mentioned before, by using a single task, we can force our one thread to run each job in sequence so we can see how much faster we can get using multiple threads. In our web example, we can achieve a performance gain even though each HTTPS request is not compute intensive, but does take time to process over the web, and so we don't even need multiple CPU cores to get an improvement. Of course, this assumes the website can run more than one request at a time as well. This is the case with the RFC requests, as we shall see. Secondly, we can very easily convert a compute-intensive procedure call into one that runs in a thread other than the main thread where, say, our GUI code is running, thus keeping the GUI responsive. For example, suppose we have this proc compute, which calls a second proc or command called intents. If we simply call it as shown, it would run in the main thread and GUI events would not be processed until compute finishes. However, we can convert this to a tproc like so and provide for a single task. We just put a capital T in front of the keyword proc and add a tasks 1 following the body of the procedure. Then instead of calling compute 123, we use tgroup compute -run, and we put our arg list here because run could take multiple arg lists, but we only got one in this case. Or we could, if we have variables we need to pass in, we use the list command. Returning to our do URL example, the next option is import tasks, which is an option to import the tasks procedures unqualified into the thread so we don't have to prefix with tasks : And finally, we have our import list variable, which we set up earlier and we'll discuss now. One thing before we leave our little compute guy, if we wanted to import, which we would need to, the routine intents, we would put that here. If we had more than one thing to import, we could put that in braces and add something else. And one of the things we could do, in fact, is just add star, which would import every single procedure from the main that has been defined up to this point in the program, and they would all go into it. So then we could do, in fact, instead of saying intents, assuming intents has already been defined, we could just say star and we get everything. Of course, these are only procedures, so if you have Tcl 00 code or something else that's not a procedure, you will have to do something different to get that into your tasks thread. Okay, so returning to this third parameter, which in this case we're using this list variable, which we set up above in this code. So iList is a list variable where each item in the list can be either the name of a procedure or procedures to import, which allows wildcards as permitted in the info procs command. Or if it begins with a dash, it is a Tcl statement to insert. These imports and statements will be loaded into each thread we create and will precede the do under URL script. The script will also have a forever loop around it, which is how a single thread will process multiple arg lists. There will also be some error catching code included. So in this case, we first specify our timestamping procedure, time, with a capital T, and then set up two debug variables, followed by the package commands needed to use the HTTP package on HTTPS websites. Each thread will execute these statements only once, so this is the preferred way to do this, rather than including them in the tproc code body itself. Next, we will discuss the code that calls tgroup to feed our jobs asynchronously to the doURL task queue, where the task will be waiting for jobs to do. When there is only the one task, it will end up pulling jobs one at a time from the queue. Here we are working on URLs that range from to 2, and we feed our queue one per time through the for loop. First, we set the URL to this HTTPS website, and we're plugging in our number. Since the RFCs are entitled RFC and a number .html, we're using the for each subcommand of tgroup, which is given a single arg list at a time, and we're only sending the first two parameters. So the third, the debug param, will be defaulted, which, as we saw above, defaults to a Boolean false for no debug output. You may have noticed that I forgot and left in a yes for the debug parameter when I was testing this out before. Anyway, this is what it would look like if we only send in the URL and the value n. The tasks will begin removing arg lists from the queue as soon as they are inserted. Each task, once initialized, will call a low-level task command twait, which wakes up anytime something is inserted into the tasks queue. Twait does this using a mutex and a condition variable. However, this occurs behind the scenes as part of the code that tproc built into each thread. After we insert all of our URLs into the task queue async, we will then wait for all of them to finish. Finally, we have our output code. As mentioned in the first video, tgroup creates an array of the same name as the tproc, which is do under URL in this case. And this will save the results using indices that are rvar, star, where star goes 0 to n-1 for the total number of times the tgroup for each command was used. In our case, we compute the numbers so that they start at index 0 by subtracting the from variable from our current n in the loop. This code actually only prints out the first 5 and the last 5 results, and between them it puts out an ellipsis. And we finish the run with some additional output where the tdump command will tell us which tasks did which jobs, which in this initial case will be all of them by a single task. We also output the amount of time the jobs took, including the time to create the tasks, which is about, I believe, 13 milliseconds per task. So let's do a run now, and we will use our 64-bit Tcl running version 8.6.12. Actually, before we run this, I also inadvertently left this code with the withdrawal was commented out, and we added the GUI button. First, we're going to do that without that. Okay, here, let's run it now. Okay, here we see our output with the first 5 and the last 5 RFC requests, along with their size in characters. We see here that the time to create the task was 13 milliseconds, and the job to do the 20 requests took 2.6 seconds. Also, we'll notice here that we get one task named do a URL 0, and the count was 20 since it had to do all the work by itself. Next, we will try this with a different number of tasks to see what the timing can be. First, we'll move this window over a little bit. And we'll go up here and we'll change the number of tasks. Oh, I don't know, let's say 10. And we'll run this. And let's slide this out of the way a little bit. Okay, and we can see that the time to create the 10 tasks has increased to 220 milliseconds. However, the time to process the 20 URLs only took 385 milliseconds. So the total there would be, about 600 milliseconds versus 2.5 or 2.6 seconds. So overall we get a speed up by using 10 tasks. Now if we go back to this window where we ran only the one, we can type in to the console the tdump command, and it will give us information. Let's move this over and widen the window a bit so we don't get any wrapping. And we can see the kinds of information that's there. Here's our condition variable. The count was 20. We didn't have any errors. The return variable, you see, went into the array do under URL rvar, 19, because that was the last one going from 0 to 19. Here's our mutex. The PID is the parent ID, but in this case it's actually the caller ID. And this caller ID is 2598, turns out to be the main thread. At this point, we've processed everything, so the queue is empty. But here was our last result, which was RFC20. And the script is here. If we wanted to look at the script, we could dump out the script. This is the script that we actually created in the tproc command. The share attribute is null because we're the main task and we don't have anybody else sharing our queue. Our task ID is this one ending in 3564. And there's a user value that is unused and is available for a user program to store information in if desired. At this point, we could also type in a command tset and do under URL 0 and script. Now before I do that, I'm going to clear the window, and this is going to dump out the actual script, and we're going to do a Control-All, copy that script, move these out of the way, go into our editor, open up a new window, and we're going to paste that in, and we're going to say that this is a Tcl TK file, so it will color encode things. And one thing we can do here in this editor is fold all of the by all the procs, and we can see that at the beginning of the script that was generated, we have a number of our global variables that we set our values to, and then here's all the procs that we imported, and the last two are the do URL proc itself, which looks like this, and time is down here, and there's also where is it? Okay, in order to see this, okay, here's there's a comment put out in there that tells us what we imported. So we imported do URL and time, and we issued 5 commands. The 5 commands were 1, 2, 3, 4, 5. And so here's do URL, and here's time. We can also see here that we have a forever while loop that surrounds a call to twait, which gets all the args and then calls doURL using the arg expansion operator and then does a t return. So those are the actual low-level task procedures that are used in the script that we create with a tproc. But as you can see above here, tproc came in as just a bona fide proc. We also have a catch, and if necessary, we'll load up TK and we'll do a message box if there's an error. If there was an error during the task create, we'll do likewise, but we'll also set up into the error attribute of our task, we'll put the error code if necessary. Where this tends to occur is if you say you misspell a package require statement. Anyway, getting back to our code here, to see what an error looks like, let's just put in something here. We'll set m to the expression n divided by 0 and n divided by 0, and we'll make that into an expression. And if we run this, notice we got a divide by 0 error. Here's all the threads we just ran, and we can get this message here 10 times because we've got 10 tasks, so we can just exit quickly here. Okay, let's remove our divide by 0 so we can continue. Now, going into this one we just ran with the 10 threads, let's look at a couple other things we can do with the tdump command. If we say want to look and see if there were any errors, we could do that. If we're interested in the return values, they're not called that. Sorry, they're actually called results. No, it's not. It's called result, singular. So here's our results that each one, the last result that each one of them did. If we wanted to, we could do a tset do under URL 9 user some value here, and then we could say tset dash user, and we got to add the what am I doing? Tdump, sorry. Dash user. So this is just a handy little place that you can store and retrieve values from your tasks if you don't want to set up TSV variables on your own. If you wanted to see just the data without any the data on the tasks itself, whether they're still running, you can do a quick, just give it something that doesn't exist, that it won't find in the search. It'll tell you you can get all the task names and their thread IDs. You can also get their threads dash what's comma TID tdump tid. And if you want more than one item, say you want the count as well. This is a regular expression that follows the after the dash, and by using the vertical bar we get the regular expression or, and the match is going against this data plus this data. Okay, next we're going to enable some of the debugging, and the way to do that is to go into the tdrew call, which was sending the URL and the number, but it left off the parameter here, and so we're going to run this, and let's go back to just one thread for a moment. All right, I was testing that out offline here. Okay, so we're going to run this, and now what we see here is that a window comes up which contains the debug statements, which is, if we look at the code, and where was it? Okay, it's this statement here, this putc statement. And so the output went into a separate text window. Now if we look at this this window, it has some commands here. This is just to make it wider in case it's wrapping, and sometimes that's easier. I find it hard to grab Tcl windows for some reason. We got a button, we can clear the text. We have an option to turn putc output on and off, and we have a pause button here. The big button here tells us the task ID or thread ID, the task name, and can also be used to quickly exit the program. Okay, so let's run this, and notice we can hit the pause button, which would allow us to look at things before it's finished. And for example, we can do a tdump, and we're going to look for the Q. If I spell that right. And we're limited right now in tdump, which defaults to a width of maximum width of 90. But let's just make that so we can see all of the items in the queue here. Here it lines up kind of nicely there. So if we just run tdump, we see that the count is, it's done 13 up to this point. The last global variable that was set in the main, in the do URL array, used the index rvar, 12. Here's the result, the last result. Okay, so let's now go back and set the tasks to how about 4, and we'll run this again, and we'll notice that we got 4 windows here. I'm not sure what the algorithm is for placing windows, top-level windows in Tcl TK when you don't position them yourself. So it turns out that that's what we wanted to do here. And so we're going to, well, first let's take a look at this for a second. You can see that this task worked on RFC 2, 8, 10, 15, and 20. This one did 4, 6, 12, and 18. So they're dividing up the work amongst themselves. And if we do a well, okay, you can see it over here. Each one of them did 5. Okay, but let's kill this off and let's go back to this code up here. And I'm going to reverse this. I'm going to comment out the withdrawal, and I'm going to re-enable these two statements here. And so when we run the program this time, we're going to get a button over here, and this button is going to call a procedure that kind of straightens out the windows a little bit for us. Here's the routine. So if we go back and say we do 10 of these and we run it again, you see how we now have 2 requests per each in each window. Now alternatively, we can set this debug parameter. 0 means any put Z statements end up going to a separate window, but if we set that to a 2 and we run this again, then all the output from those tasks ends up going to the console window, and we prefix each message with the task name and a bang character to simulate a little straight line. And that's an alternative if you don't want to have 10 windows popping up. Let's change this to 50, and we'll run it again. So as you can see, it did all 50. Notice it came out pretty quickly. Whereas if we had just the one task, you can see how long it's taking to do them. So for 50 it took 6.3 seconds. With 10 tasks, it only took 0.7 seconds to do that. Anyway, so by using the number of tasks, you can very easily just change how many server tasks you have running. Anyway, this video is getting pretty long. It says 37 minutes. So I'm going to have to shut it down, and maybe we'll have a third video. So thanks for listening.